Okay, there were three parcels, A, B and C. The mass of parcel B was 3/4 of a kilogram less than the mass of parcel A. The mass of parcel C was 2/3 of a kilogram more than the mass of parcel B. Now, if the mass of parcel A was 4.5 kilograms, what was the mass of parcel C? So again, a question where there's a lot going on, and we know then we need to be careful, and we need to be careful about a couple of things. One, that we've got times where something is more than something else. We've got times where something is less than something else. But we've also, if you notice, we're dealing with fractions here, and we have different denominators. So we are probably going to be having to change fractions into equivalent fractions with the same denominator. So from reading the question, we're already starting to think of all of those things. Okay, so we've got A and we've got B and we have got C. Right, let's have a look. The mass of parcel B was 3/4 of a kilogram less than parcel A. So I'm actually going to start with B, and we're going to just draw a randomly sized block to represent B. Now, if that's B, then A, let's look at A. It says B was less than A. Okay, B is less than A, so A is bigger. Okay. And by how much is it bigger? This is 3/4 of a kilo. So we know that this bit, if I say that these two bits are the same, let me use a different color here. That's 3/4 of a kilogram. Okay. I'm not going to put in kilograms there just so that we can still see it. Right. Okay. So that's A, that's B. Okay, I've captured those. What about C? The mass of parcel C was 2/3 of a kilogram more than the mass of parcel B. So again, C is bigger. Okay. All right. Now, 3/4 and 2/3 are very similar in size. 3/4 is a smudge bigger. I think that's probably about right. It doesn't really matter as long as you label things appropriately. So that's the point at which these two are the same. And then what's the difference? C is 2/3 bigger. Okay, right. I think, let's see, have we captured all of the information? Well, yeah, in terms of the relative sizes of the bars. Okay, now we're asked, if the mass of parcel A was 4.5 kilograms, what was the mass of parcel C? Okay, so we're going to start here with A. And we're told that A is, so the whole of A, there we go, is 4.5 kilograms. Right, well, this is in quarters and this is in halves. And what are we going to do? Well, we want to find out what the value of this is, okay? Because we want to use this to help us identify what the mass of B and C are, okay? And this is, the start point that we have. So we want to take away 3/4 of a kilogram from 4.5 kilograms. Now, it's not a difficult thing to do. We could just think that 4.5 kilograms is the same as 4.75 of 2/4 of a kilogram, and we want to take away 3/4. And you could probably do that in your head because you're going to take, so there's the 2/4 to take away. which would leave us with 4 kilograms. And then we want to take away another quarter, which would leave us with 3 3/4 kilograms. I'm going to just put that in there, 3 3/4. But let's think how else we could do that. So this is 4.5. Because we've got quarters here, we've changed it to 4 2/4. Let's change it from a mixed fraction. Okay, so in this 4 wholes, we're going to have 4 times 4 will give us the number of quarters. So that's 16. There's 16 quarters in this, plus these two is 18 quarters. So we have 18 quarters, and we want to take away 3 quarters. Okay, and 18 take away 3, that is going to leave us with 15 quarters. And then we have to think, how many wholes can we make out of 15 quarters? So how many 4s fit into 15, and what's the remainder? Well, 3 times 4 is 12. Okay, 4 times 4 is 16, so that's too much. Okay, so 3 times 4 is 12, so there's 3 wholes. Okay, 12, and that leaves us with 3 quarters left over. Okay, so that's another way we could have done it. But there we go. There's the 3 3/4 we know this part is. And if this part is 3 3/4, this is also 3 3/4. And according to the model, you know, because we've drawn this, we know we can have confidence in it. That's also 3 3/4. Okay. So we know the mass of parcel B, that's 3 3/4 kilogram. We now want to work out the mass of parcel C. This is the actual question. So here we have 3 3/4, and we need to add 2/3. Okay, we have different denominators. Okay, and what we can do is, we know we've got 3 wholes. So let's add these two together. Now we've got 3 quarters, and we want to add 2/3, and we need to change to common denominators, and the common denominators is if we change these to 12ths. Okay, so how do we get from quarters to 12ths? Okay, so how do I get from 4 to 12? I multiply by 3. And that means I have to, whatever I'm doing to the denominator, I have to do to the numerator. Okay, so 3 times 3 is 9. So 3/4 is equivalent to 9/12. And then we're going to do the same over here. We'll go this way. So I want to have, again, 12ths. How do I get from 3 to 12? Well, I multiply by 4. Going this way. Okay, so multiply by 4. And then 2 times 4 is going to give us 8. So we have 9/12 plus 8/12. Okay, and that is going to give us 17/12. Okay. So what have we got then? How many wholes have we got? Well, we've got 1 whole there, because 17, we need to take away 12. That will give us the 1. What have we got left over? We have got 5. So 5/12 added to the 3 that we still had. That means altogether this is 4 5/12. Okay. Now we could also have just change these into 12ths as well. Okay, and then added that to the amount, and not had to remember to add this 3 back in, if that makes sense. Okay, so not too tricky. I think the model does help to see what's going on, and said you just need to pay attention. When you're reading something like this, what are you going to have to do? Whenever you have different denominators, you need to be thinking that you might be having to change some fractions into equivalent fractions that have the same denominator.